Hi, this is Mrs. Ringrose, and we are studying pre-calculus together. So I know this is our first video, but you want to take notes just like if you were in class for real. And what you also want to do is star anything that doesn't make sense to you. What's nice about a YouTube video is you can pause me, you can make me talk slower, you can make me talk faster if what I'm going over is too easy for you. This video is for you to, try to get the most out of your learning. So please take advantage of it. So why do we do transformations? Well, in real life, a lot of the problems that you come across are problems that can be modeled based on functions that we already know, such as your parent functions that we've studied. So here's the one that you know the best, right? Y equals mx plus b, f of x equals x. So in the past, the ways that you've been told to transform it is maybe you've learned to do a vertical shift, right? Move it up 5 spaces. Maybe your vertical shift is down. You've also been able to transform it by making it go steeper faster by changing the slope. Or maybe you want to make it go not as steep by making the slope smaller. And we're going to do those same kind of things with our other parent functions. So before you move on, you should probably take out your parent function sheet, and hopefully you have most of them studied by now. Okay, and all these slides are going to be posted on Google Classroom, so you can go ahead and copy this down now or copy it down later. Again, you can pause, get some time to copy this down in your notes, whatever is best for you. So a rigid transformation is a transformation that only changes the position of the graph. So if you have something that looks like this, this is just a random cubic. This is not the parent function of x cubed. But if I took this and I shifted it horizontally, this would be considered rigid. If I shifted it vertically, it's a rigid transformation. Even if I flipped it, this is considered rigid because even though it's going different directions now, it's still the same shape and the same size. A non-rigid transformation is when you take a function. No, that didn't work. Oh well. It's when you take a function and it does not keep the same size or shape. So maybe it looks like this. So now this is a horizontal shift, or maybe a vertical shift. Not shift, but vertical stretch. And now the size and the shape is different, so that would be non-rigid. So some of these translations, again, I'm going to try to get through quickly because you've seen them before. Okay, so here's your parent quadratic, right? F of x equals x squared. And you might have learned this in Algebra 2. If you add something outside of the function to create a new function, that's going to cause a vertical shift up or down. So if k is positive, it goes up, such as this one. Right? So all I typed in was f of x plus 4, so it shifted up. Or if k is negative, what happens is it gets shifted down, right? So that's the blue one that just appeared is your graph of f of x, and then I subtracted 5. Okay, a horizontal translation will be when you take h and you subtract it from the input before you even put it into the function. So again, if we look at our parent function and x squared, and now if you're looking at the next one, what I did was I took the plus 4 and I put it inside the parentheses to add it to the function before, and it gets shifted to the left. So if h is greater than 0, it actually gets shifted to the left, but it seems kind of counterintuitive because once you see it in the equation, it becomes x plus 4. But as I had said once before in class, it's like the graph is happening sooner. So that's why it gets shifted to the left. When h is less than 0, it's going to look like x minus 5, and it's going to happen later. Okay, and now on to reflections. So this transformation is considered rigid because it's not supposed to change the size or the shape. but it basically produces a mirror image with respect to a line. Usually we talk about the y-axis or the x-axis, and actually we don't even talk about the x-axis that much because often that'll make it no longer a function. So we just talk about reflection over the y-axis often. So again, when you have the negative on the outside, it changes all of the outputs from positive to negative or negative to positive. So if we are going to look at our parent function of the square root of x, sorry, this is, okay. So if we're going to look at this parent function, the square root of x starts at the origin, and then we keep this negative on the outside of the function, then what happens is it's supposed to reflect across the x-axis, because what happens is all the output values, like 4, if I put 4 in, I get 2 out, it becomes 4, and then the output turns negative to negative 2. If we take the negatives and put it on the input, it shifts the graph across the y-axis, because we're basically taking all the input values and making them negative before we put it in the function. So if you're looking at a table, you would change all the inputs to negative, and then you'd be good. All right, so now we're just going to do a couple of tests, and again, I really want this video only to focus on the rigid transformations, because I think that the non-rigid will be better in class. So which parent function is this? Hopefully you know that this is f of x equals 1 over x. Okay, it's got that undefined kind of characteristic. It looks like a hyperbola. And now we're going to use this in our family to write new equations. So this graph, when we compare these two, you have to ask yourself, does this look like a vertical shift or does this look like a horizontal shift? Well, because it's still not passing through x equals 0, it looks like everything has been shifted up. And it's kind of tough to tell from this graph, but it kind of looks like it's not crossing the line y equals 3. So we're going to say that this function is a vertical shift of up 3 spaces. Okay, so that's what a vertical shift looks like. Next, we're dealing with the same parent function, but now it looks like the asymptote has been shifted over 2 spaces. So it looks like a horizontal shift. So we know that this is going to be 1 over, and because this is a horizontal shift, we want to make sure that the 2 is in the bottom, that's happening inside the parent function to the input and not outside the function to the output. So now the only question is this going to be x minus 2 or x plus 2? So because it has been shifted to the right, we want this to be x minus 2. And because the graph is happening later, that's the way I like to look at it. You can always do a test, because if I try to evaluate this function at h of 2, then what happens is if I put a 2 in here, I get 1 over 0, which is undefined, and that's where my function is undefined. So it looks like I did a good job with that. So that's just some really quick, brief examples with vertical and horizontal translation. And then next, and then we'll wrap this up. Which parent function is this? It is f of x equals x squared, right? Looks like the quadratic. And what's happening with this graph? Has it been reflected sideways, up, down? What's going on? Well, it looks like all the outputs went from positive to negative. So if we can say that about the outputs, then we know that g of x is equal to the negative of f of x. Therefore, g of x is equal to negative x squared. Okay, that's my concave down parent quadratic function. All right, so then we're going to combine a couple skills here, because it looks like not only has it been flipped down, but it's also been shifted over. So 1, 2, 3, 4, 5. Looks like it's been shifted over 5. And it's a horizontal shift, so I would have started with x minus 5 squared and then the negative goes outside because it's been shifted, right? So this minus will shift it to the right, and the negative flips it down. And again, you can always check a value or two to make sure it works out for the domain. So let's try 4, and that should give me -1. Right, so h of 4. Okay, and that checks out. So it looks like hopefully I got my new function correct. Let's see, what else we got? All right, so I'm going to stop this right here. Hopefully this was a good introduction or review of vertical and horizontal translations, a little bit about reflections. We're going to start tomorrow with some dilations and kind of go from there. And if you have any questions, make sure you have something starred or written out in your notes, and you let me know. Thank you.